Let me explain through these examples. So we're going to obtain the cumulative distribution functions from a given probability density function of a continuous lambda variable. Okay, when we look at this density function, we notice that here we have interval of 0 to 1, which is the function of 1 over 2. And from 1 to 2, we have the density function of 1 over 5x cubed. Okay, the rest is 0. So let me show you how I'm going to apply the arbitrage to find the cumulative distribution function easily. Okay, so first of all, we draw our arbitrage in the form of timeline. Okay, so we have the range from the minus infinity to infinity, and we fill or we insert the value of x. We have the 0, 1, and 2 based on the given density functions. Okay, after that, we fill the value of the x interval. Okay, remember that I'm going to change my value of x in the parameter t, and so on for the next interval. So also change in the term of parameter t. Okay, after this, we have to add on 2 extra interval from the beginning part, okay, which is t is less than 0. Okay, we just choose a sign which is opposite from the interval, the second interval. Okay, so another one is the t greater or equal to 2. So you will notice that okay, the sign of this is just opposite of the t less than 2. Okay, so the next step is that I have to fill my given density function corresponding interval. So we have the 1 over 2x for t greater or 0 and 1, and 1 over 5x cubed for the interval from 1 to 2, and the rest is 0. Okay, this means that we have 4 interval functions that we need to integrate, okay, to find our cumulative distribution functions. Okay, so first of all, I draw my interval. I divide it into 4 sub-interval parts. Okay, I proceed with the first sub-interval. We have t less than 0, which by the function is 0. Okay, so we will have my first one as the ft. So we have since the function is 0, so I have my cumulative of 0. Okay, so after that, I evaluate my cumulative for f0. Okay, so I will have my f0 equal to 0. So after this, we proceed to the second interval here. So we just look at here. I have to find the cumulative from f0 plus the integral of 0 to t. So f0 plus the integral of 0 to t, the function is followed through by the second interval, which is 1 over 2x. Okay, since the f0 is the value of 0, I take from the first integral. So I proceed with my integral, and then I have my cumulative at t squared over 4. Okay, after that, I need to evaluate my value of f1. So based on the function t squared over 4, I have the value of 1 over 4. Okay, after that, I proceed to the third interval. I also repeat the same process. So I need to find the cumulative of ft from f1 plus the 1 to t. Okay, so as usual, okay, the function that I choose now is 1 over 5x to the power of 3 based on the interval 1 to 2. So the value of f1 I took from the second interval, which is 1 over 4 plus the integral of the 1 over 5x cubed. So I have my cumulative of 1 over 4 x to the power of 4 over 4 plus 1. After that, I need to evaluate my value of f2. Okay, so I have the value of 1. Okay, please make sure that for the second last interval, so you will get 1. Okay, because our total probability is 1, so make sure that the second last, the value should be 1. Okay, we'll proceed to the last interval, which is the t is greater or equal than 2. So I have my f2 plus the 2 to t. Since the function 2 to t is 0, so I just copy down the value of f2 from the third interval. So I have the cumulative of 1. Okay, so this is our final part of the interval. So please remember to write down the cumulative function, okay, in the piecewise functions form.